Hi everyone. So welcome to my first video lesson ever. I'm going to teach you about arc length and area of a sector. Also after that, we're going to talk about ratio of areas. So let's get to it. So yesterday we learned about area and circumference of a circle. So remember the area is pi r squared for the formula, and you're trying to find the area inside of the circle, and the circumference is the distance around the circle. So for our first problem, we're going to find the area and circumference of a circle that has a radius of 5, just as review. So we're going to find the area of the circle. So that's going to be pi r squared. So the area is going to equal to pi times 5 squared, or 25 pi and units squared. And that's the area. Circumference is going to equal to 2 pi r, and that's the distance around the circle. And you're going to say 2 times pi times the radius being 5. So my answer will be 10 pi units. Okay. Let's box those up. All right. So what I want to introduce today is the area of arc lengths and area of sectors. Now, an arc length is a portion, like from here to here. It's like a portion of the circle, so it's a portion of the circumference. Whereas the area of a sector is this space inside here. So there's two formulas for that. The first one is the area of a sector. So you're going to say area. Okay, hold on. So the area of a sector is equal to arc degree over 360 times pi r squared. And what that is it's a fraction, that's your fraction right there, of the whole circle. So it's this fraction right here of the area of the entire circle. Whereas arc length, so we're going to call that AL, is a fraction again, arc degree over 360 times 2 times pi times the radius. And again, so if I'm thinking all the way around the circle is my circumference, an arc length might be just from here to here, or we could say it's from here to here, but it's a portion or a fraction of the distance all the way around. So we're going to use those two formulas for a couple other problems. First of all, let's just try to familiarize ourselves with what these are. These are circles with area that's filled in. So that's a filled in complete circle. So the area of that, using r as my radius, but no actual numbers, is just pi r squared. It's the entire circle, and the circumference, 2 pi r. Where this one is a half. This is half of the circle. So this is actually 180 degrees over 360, which most of you know is a half, times pi r squared. So we can even say that this is 1/2 pi r squared, or we can just write it as pi r squared divided by 2. Circumference, again, because we're only going around half of the circle, is 2 pi r divided by 2. 2's cancel, so that's just pi r. The area of this is just like what we were just talking about. That's a sector. We're going to fill that out just like this. But instead of using 180 over 360, we're going to use 120 over 360. So 120 degrees over 360 times pi r squared. And this we can cancel. This is 1 over 3. So my final answer for this problem would be pi r squared over 3. Okay. This one, being a 90-degree angle, to find the area of that, is 1/4 of the whole circle. Or you could write it as 90 degrees over 360 times pi r squared. So again, these cancel. This is 1/4. So my final answer would be pi r squared over 4. And this one right here is just n degrees. So we would just write that as n degrees over 360 times pi r squared. And that would be my answer for that problem. So here's 2 examples. So given the following circles, find the arc length. So I'm just looking for the arc length. So I think that should be AE. So anyway, I'm going to look for this arc length right here. And CD, I'm going to try to find this arc length, okay, right around here. just because my angles are the same doesn't mean I'm going to get the same arc length, because it looks to me like the radii are different. So I should get different answers for that. So for find the arc length, we're going to go arc length equals arc degree, which is 60 over 360 times 2 pi r. And solving that, these are going to cancel the zeros, divide by 10. This will become 1 over 6. Also, though, I can cancel this 2 into the 6, and I'll have a 3. So it looks like my final answer will be pi r. Well, r is 6 over 3, so that's 2. So I'm going to get 2 pi for the area of that, for the arc length. For this arc length right here, so we have arc length is equal to 60 over 360 times 2 pi r. I'm going to put the r in now. The radii. This becomes canceled. We have 1 over 6. I'm going to cancel 2 into 6, and I'm going to get 3. And then I'm going to cancel, divide in the 3 into the 9 and get 3. So what I have is 3 times the pi. And that's my answer for that. Now, this just goes to show, again, just because the two central angles are the same doesn't mean my arc lengths are going to be the same. And as you just look at it, this one does look smaller than that because the radii are, different lengths as well, or different degrees, different lengths. Circle 0 has a radius of 9, and the measure of angle AOB is 120 degrees. So we need to find the arc length. We also need to find the area of the shaded region, okay, the area of that sector. So let's just find the arc length first. The arc length is arc degree over 360 times 2 pi r. So our arc degree is 120 over 360 times 2 times pi times a radius. These cancel. 1 over 3. I'm going to cancel this 3 into the 9, and that makes 3 up there. And so I have 3 times 2, which is 6. So my arc length is 6 pi. That's my arc length. To find the area, we're going to use a different formula, which is arc degree over 360 times pi r squared. And so my arc degree is 120 over 360. Get a little bit more space here. Times pi times my radius. My radius is 9 squared. These cancel. I get 1 over 3. What I'm going to do is pi times 9 over 3. 3 goes into 9 3 times. 3 times 9, 27 pi units squared. That's the area of that sector. Okay? All right. Next problem is to find the area shaded in, the shaded region bounded by x, y, and this should probably be arc x, y. And so what's happened is we are looking for this little shaded region right here. What you notice though is we sort of need a plan of action, because we need to actually find the area of the entire circle minus this little area here, minus this triangle. So we need a fraction of the circle minus this little triangle, which is this. Okay? And so now, let's write this out. So we're going to find the area, and that's going to be arc degree over 360 times pi r squared. That's going to give us this whole area here, as if it's going to give me the area of that. But then I need to take away this area right here, which is this top part. Okay, so that's my goal. So I still need to take away the triangle, which is 1/2 base times height. All right, so let's see, arc degree. So this is a 90-degree angle. So that's going to be 90 over 360 times pi r. What's r? R is 10 squared minus 1/2 the base times the height. And what you need to remember about this is that the base and the height are perpendicular for the triangle. You have to find the base and the height. And in this case, it happens that it's perpendicular anyway. So this is 10 also. So base times height. And those are perpendicular. Okay, so we have zeros cancel. This becomes 4. We have 100. 100 divided by 4 is just 25. So that's 25 pi minus 2 goes into 10 5 times. 5 times 10 is 50. So this is my area of that little blue area right there, that shaded region. It is units squared. I do want to make sure that when you do this, that you don't add these up. Those are different. Unless you change pi to 3.14 and you multiply it by the 25 and then subtract 50, then you could get an answer. Ratio of areas. So this is the second half of what I want to teach you. And this is based on comparing triangles. So the first theorem, which is right here, okay, is if two triangles have equal heights, if their heights are the same, then the ratio of their areas equals the ratio of their bases. So if I went from triangle 1 to 2, and I'm comparing their heights, which are equal, then the ratio of their areas is equal to the ratio of their bases. So it'd be 12 to 7. This is the second one. It says that if two triangles have equal bases, then the ratio of their areas is equal to the ratio of their heights. So here we have two triangles that have the same base. So if I wanted to find the ratio of their areas, well, it would be equal to the ratio of their heights. So that would equal 2 over 6, which is 1/3. Okay, and you can actually try that out. Just check, well, how do you find the ratio of the areas? Well, what are the areas? This area for this triangle right here would be 1/2 base times height. So 1/2, 4 times 2. 2's canceled, so that's 4. Then the second one, again, would be 1/2 the base times the height. And then 2 goes into 4 twice. 2 times 6 is 12. If I were to compare the areas, I would get 4 to 12. Well, 4 to 12 reduces to 1 to 3. And so basically what that's doing is it's allowing you not to have to find the area and just write the heights as a proportion. And then we have another one, the third one, which says if two triangles are similar, then similar proportional, meaning then the ratio of their areas is equal to the square of their scale factor. So a scale factor is where we compare one side to another, if you recall that. 6 to 9. So we can reduce that by 3 and we're going to get 2 to 3. This right here is my scale factor, okay? And if this is my scale factor, what ends up happening is to find the ratio of their areas is equal to the square of their scale factor. So that means that I'm going to take 2/3 and square that, and I'm going to get 4 over 9. So that right there is the ratio of their scale factor. So right there, ratio of their areas. So this is just saying this again. If their scale factor is A over B, okay, then actually the ratio of the perimeters of two triangles is also A over B. That's not going to change. But the ratio of their areas is A over B squared, and that's going to be A squared over B squared. Okay, so just with numbers, let's just do that one more time. So with numbers, if I said, let's say 2/5, and so my scale factor is 2/5, meaning I have a triangle here and I have a triangle here that are similar. And we can go side to side. And so their scale factor is 2 to 5. So if that's the case, and that's their scale factor, then what we can do is find the ratio of the perimeters. I don't have to know the entire length around the whole triangle in order to find the ratio of their perimeters, because ratio of their perimeters is exactly the same as the scale factor. These right here are the same. But if I asked you what the ratio of their areas were, then I would take 2/5 and I would square that, and I would get 4 over 25. And so that would be the ratio of the areas. And remember, this only works with similar triangles. Okay, so find the scale factor of these two similar triangles, the ratio of the perimeters and the ratio of their areas. So you need to decide, which one do you want? Which side do you want to compare? I'm going to compare, 8 to 12. So 8 to 12, we're going to reduce by 4. Always reduce first. And so reducing this by 4, we're going to get 2, and we get thirds. So now we have our scale factor is 2/3. Okay. The ratio of the perimeter is exactly the same thing. Okay. Now, a couple of things before I just tell you that, and I'm going to show you that. What happens with the scale factor is I chose 8 to 12. You actually can just choose 6 to 9. And if you reduce that by 3, you get 2/3. I could have chosen 10 to 15 and reduced by 5 and get 2/3 again. So it doesn't matter which side you choose; you're all going to have the same scale factor. So if the triangles are similar, and so that's really important. Just to show you, because I tell you that the ratio of the perimeters is exactly the same, we can prove that, and we can prove that by saying, add these up. We have 10 plus 8, which is 18, plus 6, which is 24. This one, we've got 9 plus 12 is 21, plus 15 is 36. So that when I'm looking at the I'm just adding the perimeter. So I'm adding them all up. So if I go 24 to 36, and let's say I divide by, you want to divide by 4? So let's divide by 12. If I divide by 12, I'm going to get 2/3. So again, this was my ratio of perimeters. By just adding up all the sides, I'm going to get the same thing. It's sort of like a shortcut. Again, ratio of areas is going to be 2/3, but squared. And so that's going to be 4/9. Okay. But again, you can always prove it if you're doubting Thomas here. You can say ratio of areas. I'm going to find the area. So the area of the first triangle is 1/2 the base times the height, and then the second triangle is 1/2 the base times the height. 2 goes into 12 6 times. 9 times 6 is 54. And then 2 goes into 8 4 times. 4 times 6 is 24. Let's reduce those. I'm going to reduce by 6. So if I divide this into 6 into 24, I get 4. If I divide 54 by 6, I'm going to get 9. And so that's the ratio of my areas. So I can definitely work it out, but it's just a shortcut. Okay, it's just a shortcut. All right, so this is sort of going a little backwards. So if I have two circles and their areas are 9 pi and 25 pi. So I'm just going to draw a couple of circles. If this one is, the area inside is 9 pi, well, area is equal to pi r squared. So if I were to divide by pi, those go away. And I have r squared equals 9, which basically means this triangle is 3. And likewise, this triangle radius is going to be 5. So what is the radius of each circle? The radius is going to be 3 and 5. So what would be the ratio of the areas? Well, that's going to be 3/5 squared, which is 9/25. But you also could just take 9 pi and go to 25 pi. Pi's cancel. Again, you get 9/25. And lastly, what is the ratio of the radii? Well, that's just 3 to 5. A rectangle has a perimeter of 10 inches. So if the perimeter, so we have a rectangle, okay, and then we have another rectangle. And it says the perimeter for the first rectangle is 10 inches, and the perimeter for the second triangle is 20 inches. Okay, and what is the scale factor? Well, scale factor is comparing the two sides, which is the same as comparing the perimeters. So we have 10 to 20, which is just 1 to 2. So my ratio of my perimeters is 1/2, but so is the ratio of that, so is my scale factor. In order to find the ratio of my areas, all I have to do is take 1/2 and square that. And so that's just 1/2 times 1/2, which is 1/4. And that's going to be the ratio of the areas. Okay. So what you should do now is turn off your computer and get up and go around the room, because you have an around the room assignment. So till next time, bye.